Hello students, my name is Shayan Mitra, faculty member of Department of Electronics and Communication Engineering of Greater Kolkata College of Engineering and Management. Today's topic is sensors and actuators. In the previous two lectures, we have discussed what is the wireless sensor network is or WiseNet. Today we are going to describe what is the sensor and actuators is basically, which basically help to provide the or help to collect or store the data of environment or different kind of. Using sensors we basically collect the data of different kind of real-time data, basically collected using sensors and actuators. So this is the subject name is embedded system. EC703B is the code, and this is the lecture number 28. Okay, so let's begin the lecture of sensors and actuators. Okay, uh, okay, so let's begin. Okay, computer process interface. To implement process control, the computer must collect data from and transmit signals to the production process. So this is the reason why we need a sensor, computer process interface, where to implement process, any kind of process, we need data. That's the basic funda. To implement process control, the computer must collect data from and transmit signals to the production process. The production process here is the part where the data has been collected. So in this specific part of the system, the sensors and actuators, basically the basic function of sensors and actuators are taking place in the part of production process, through which the data has been collected and signals will have also been transmitted to the server and so on and so forth. So let's discuss the pros and cons here as components required to implement the interface. Sensors to measure continuous and discrete process variables, the variables that is required for process, those are process variables. Actuators to drive continuous and discrete process parameters. So this is the part we are going to discuss in a very deeply in the next part. The devices such as analog to digital converter and digital to analog converter are very essential part for this specific system. Input output devices for discrete data, these are also the requirement. Okay, so let's go to the next part. The computer process control system, how it works. The transformation process. Computer process control system. Transformation process, continuous and discrete parameters, continuous and discrete variables, sensors, analog to digital converter, input devices, computer controller, digital to analog converter, and actuators. So a computer process control system is basically the transformation process. Basically the function of a continuous and discrete variables, those are fed to the sensors and it will provide us the output. It could become in a way of voltage difference or different kind of signals that the fed will fed to the analog to digital converter. It will convert the in digital format and it fed to the computer controller where it only understand 0 and 1. So the data will be stored in the form of in a digital format, and the processor will process all those data in a digital format, and the output will again convert from digital to analog using digital to analog converter. It will convert to analog signal and it will provide us the output. So the continuous and discrete variables, those are fed to the sensors and through which it goes to the computer controller. It process itself, and through the actuators it get out and in same form as the continuous and discrete parameters. So this is the specific transformation process in computer. This is the interface for the outer world. All the data that has been collected and restored in a computer device or computer storage system, in a memory system, using the computer, and the processor also process all those data in the computer controller, and according to the that output will be provided in the continuous and discrete parameters. So this is the computer process control system. Okay, so let's go to the next slide. So what is the function of sensors? That's what you have understood here, that any kind of natural signals such as temperature, wind speed, any kind of uh, continuous time variables, any changes or any kind of data that is required to be recorded, we use sensors, because sensors basically it created from piezoelectric effect. Different kind of materials are used, such as Rochelle salt are being used, where this kind of material, what will happen, suppose we have provided a pressure in one segment of the Rochelle salt, and in the another segment there is a change of the shape, and that change, any kind of change in the such kind of materials, it will create a specific voltage difference. Now if we connect those voltage difference, we will get a specific voltage signal according to the changes of the of the input material. Suppose the input signal are wind speed. Now as the wind speed is changing, as the wind speed, the suppose the wind is blowing in a speed of 5 kilometer per hour. Okay, normal weather, 5 kilometer per hour, 10 kilometer per hour, that specific data will be can be collected through the sensors. So suppose there is a timeline where on 23rd December of from 5 p.m. to 10 p.m. The wind speed of Kolkata, supposedly in between 5 kilometer to 10 kilometer per hour, max to max 5, suppose 5 kilometer per hour for this hours. So those data will be stored. So different kind of data, such as the whole wind speed for the December month of city Kolkata. So all those data will be can be captured by the sensors. So all those data will be again, so as the continuous signal can be captured, we use this control signals, continuous signals output, send it to the analog to digital converter, and it stored in the form of 0 to 1 format. So now if from the SQL database we need to collect all those data, we will fed to the data to the actuators, and the actuators will create from, it will help to create the signal in the true in the true form from the digital database. So actual signals stores in a computer controller in digital format, and from that digital format we can retrieve the actual signals, actual signals using the actuators. Okay, so these are the basic function of sensors and actuators. So let's go to the take a deep dive on how the sensors and actuators works or function. Okay, sensor, these are the stimuli, these are the physical medium. This physical medium understand the, suppose temperature is the output signal variable that is needed to be recorded. The specific changes in the temperature need to be sensed and need to be stored. So how it works, the physical medium according to the temperature as a variable, as it it will affect the physical medium, and any changes in the physical medium will provide us a voltage difference also. That voltage difference will be recorded. Okay, so this is the sensing element, this is the physical medium through which the sensing element, all the differences or the changes will be recorded, senses, and this information will through the conditioning and get to the target handling, and this is create the signal. Okay, so the temperature, suppose the temperature is 20 degrees centigrade. For that specific condition, the physical medium will go through some changes, and after during those changes there will be a voltage difference, and we correct that voltage difference. It will provide us as a signal. That is the continuous time variable. So this variable will be fed to the in the previous page that we have discussed. That's this specific output will get to the DC and it will go to the computer controller as it is gone. So this is the way the sensors work, and this is the example of transducers. Micro sensors are 10 to the power minus 6 meter. This is the size of the micro sensors. So this kind of sensors basically use for smoke alarm. Different reason we use sensors to. We already discussed why we use sensors. So let's go to the next slide. So now we're going to discuss what is the transducer is. Okay, a transducer, a device that converts a primary form of energy into a corresponding signal. This is the important part. A device that converts a primary form of energy into a corresponding signal with a different energy form. Suppose primary energy forms are mechanical, thermal. Suppose what is the mechanical energy form? Wind speed. Okay, it will create a force, so there will be mechanical changes in the physical medium. According to that, there will be a creation of voltage difference that will, from that we created the signal. Next one is the thermal. Now this thermal energy, according to thermal energy, there will be a changes in the physical medium, and according to that there will be a voltage signal. So all the form of energy will be stored as a form of information. Any kind of chemical energy, optical energy, electromagnetic energy, thermal energy, any kind of mechanical energy. These are the forms of primary energy forms. So these primary energy forms will be collected as a data, as a signal. Okay. So this take form of a sensor or an actuator. Okay, the sensor, thermometer, a device that detects, measures a signal or stimulus, acquires information from the real world. So this is a sensor. Suppose we use a thermometer. So thermometer, what is the purpose of thermometer? It reads the physical temperature, real-time physical temperature of a human body. So using that, the real world problem here is the temperature of a physical body of human being. So we use the thermometer to senses the condition of the real world. So from that we extract the information that the temperature of a body in this moment, the real time, is 98.4 degree Fahrenheit. That's the normal temperature of human body. It could be 102, it could be 101, it could be 95, anything it could be. But it is conditioned to provide us the information of a human body in real time. So the real time is that is temperature. So that's a physical phenomenon, it's a very natural phenomenon. So using the thermometer, what we detect is that body temperature. So we collect the information of a real world using a specific parameters, such as we have created the Fahrenheit unit. We have created the 98.4 degree. How the measurement will work, it will all been created by human beings. So a real-time information that has been quantified as a or it could be said that information, real world information has been captured in a human form. Okay, so we measure the temperature of the physical body. So this is basically the function of a sensor. So a device that detects and measures a signal or stimulus acquires information from the real world. So it acquires the information from the real world, that was the temperature of the physical body, and it stored as a form where it could be understandable for any human beings. Okay, next one is the actuator or heater. Suppose the heater, a device that generates a signal or stimulus. So actuators, the function of actuator is to generate a signal or stimulus. A device that detects and measures a signal, it basically sensor. An actuator basically generates a signal or stimulus. Okay, so real world, from the sensor, the function of a sensor is to gather the information from the real world. Okay, and the function of actuator is to give it back the specific signal to the real world. Okay, so intelligent feedback system will be work as that way. So that is understandable. You can feel the differences, and you can also store it in a form of data in the devices. Okay, so as we're discussing, okay, so this is a real world. Okay, so let's go to the next slide. Sensor systems. Typically interested in electronic sensor convert desired parameter into electrically measurable signal. General electrical sensor, primary transducer, changes real world parameter into electrical signal. Secondary transducer, converts electrical signal into analog or digital values. Okay. Typical electronic sensor system: a prime real world from a transducer, analog signal, and secondary transducer, usable values. Okay. So the function of primary transducer is to gather the information from the real world and is sent to it create the analog signal, and the function of a secondary transducer is to create the usable values or digital values from analog signals. Okay, so this is the sensor. So this is the input signal measurement sensor, sensors data analog digital signal, microcontroller signal processing communication, where the signal will be processed. So this is the signal in using this is the part where we use the digital signal processor. Okay, so and network on display. Okay, the display part is where we collected the data, the processor process all those data, and the final output or the final designed outcome will be presented to the human or the operator that has been operating all those things. Okay, so let's go to the next slide. Example of electronic sensor system. Components vary with application. Digital sensor within an instrument, microcontroller, signal timing, data storage. Sensor, microcontroller, signal timing, memory, keypad, display. This is a handheld instrument. In case of handheld, it is such as mobile phone. Mobile phone is a beautiful example where we also use the sensor. All the sensor that has been put in the smartphone screen, we have different kind of sensors which basically help us to detect. It helps to detect the system, the human body temperature, through which the as soon as we touch the screen of a smartphone nowadays, its lights it just goes on just by sensing the human body temperature. Other it will not going to get activated. Okay, so analog sensor analyzed by a PC. This is the sensor interface, analog to digital communication signal processing. These are the communication port for PC or anything. Multiple sensors displayed over internet. This is the sensor processor and communication sensor bus. This is the functionality you can understand by that. There is a sensor processor, communication sensor bus, personal computer communication card through which the information will be shared, and so on and so forth. So it basically this picture provide us the specific picture of a specific personal computer. Using personal computer we can gather different kind of data. We use web page, we browse for our real-time information, and those real-time information is basically nothing but already stored in different kind of servers or database. The web page where you search all the data it just retrieved all those data that has been already stored. So this is the function. This is how the world works right now in today's time. Okay, so let's go to the next slide. Different kind of sensors: temperature sensor, radio frequency ID, barcode sensor, proximity sensor, vision sensor, gyroscope, compass, tilt, acceleration, etc. These are all different kind of sensors. Okay. But in your syllabus, in next lecture, we are going to describe what is the RFID is, how it works, what is the functionality of RFID. In the next lecture, that you have in your syllabus, we have the RFID is already included in your syllabus. So in the next lecture, we are going to discuss RFID. So after completion of today's lecture, in the next lecture, we are going to discuss how the radio frequency ID works. Okay. So these are the application-based sensors that are basically used. These are the different commercially used sensors. This is the casing. After the casing, it looks like this. So different kind of alarms are made of sensors. So these are the specific examples of all different kind of sensors. Okay, so let's go to the next slide. So next one is the actuators that we are going to discuss right now. Okay, so let's begin. Actuators. Okay, it's a hardware devices that convert a controller command signal into a change in a physical parameter. Okay, so that we have already discussed. Basically, it works like a sensor. The change is usually mechanical, positional or velocity. An actuator is also a transducer because it changes one type of physical quantity into some alternative form. That's the truth. Okay, an actuator is usually activated by a low level command signal. So an amplifier may be required to provide sufficient power to drive the actuator. So we use a different kind of amplifier to provide the sufficient power to drive the actuator. Okay, so this is the flow diagram of actuator, how it works. This is the logical signal, the signal processing amplification, the amplification where the signal fed to the processor. Before it fed to the processor, it goes through amplification, through which we can detect the signal. So this is the amplification part, after which the amplified signal is fed to the processor and then is again fed to the mechanism of electric and hydraulic pneumatic final actuation element, and this is the actuator sensor. Okay, this is the final actuation element. Through this is the it gives us the output. Okay, okay, so this is the logical signal part, this is the signal. So this is all we have here. The logical signal, it will be amplified, it is fed to the signal processor, then again it fed to the electric and hydraulic pneumatic different kind of processor, or their mechanism is conducted to provide the proper processing result. This is the final actuation element. Basically it's a block diagram of actuator practically. Yes, the final actuation element, and it is the feedback loop. It will always be there. A feedback loop will always be there to stable the system, to give us the proper collection of data, a proper reading of the data. Okay, so this is it. Okay, so okay, so this is the types of actuators. Okay, so these are electrical actuators, electric motors, DC servo motors, AC motors, stepper motors, solenoids, hydraulic actuators use hydraulic fluid to amplify the controller communication, and pneumatic actuators use compressed air as the driving force. So these are the pictures of different kind of actuators that basically we use. Okay, so that's it. So these are the different pneumatic devices. Okay, okay, that's it. We conclude our lecture here. So in this lecture we have understood what is the sensor is, how it works, what is the actuator is, how it works, what is the function of actuators, different kind of example of actuators. So that's where, so these are the in the first two lectures of our module 5 we have 1 second, this is the module 5, right? 1 2 1 2 3 4 5 6, yes, this is the module number 5, where we have already discussed the WiseNet, the sensors and actuators, popular microcontroller used in embedded system. So this is the third lecture. There will be another 3 lectures. Next lecture we are going to describe how the radio frequency ID works, and robotics and brain machine interface. All those things will be discussed in the upcoming next 3 lectures. Okay, so here we conclude our lecture. Okay, thank you and bye.